and welcome to our lab activity today on protists. So before we begin, make sure you have your book available and you're open to page 87. I'd also suggest that maybe you gather together some colored pencils. Colored pencils would be great for this lab activity. So if you need to go get those items, you can pause this video and go get your materials together. Otherwise, I have the microscope and the slides all ready to go. All right, our lab activity today is entitled Protists, and let's look at the problem of this lab before we begin. Remember that we have been talking about protists here throughout this week, some pretty cool unicellular critters, and we're going to be examining some of these things under magnification today. So as we look at the problem states, what are some ways protists differ from one another? We've already talked in our notes about similarities and differences, but not all of these are things that can be seen necessarily. So our lab today, you're going to be examining 4 different specific kinds of protist species. And so the question is, what are some ways protists differ from one another? As we examine these 4 specimens, how do you think we're going to be able to distinguish or tell the difference between one species and another? What are some of the characteristics that we should be looking for? And I'm going to give you a big hint here. If you look at your procedures, step 4 gives you a big hint if you're looking at bold and italicized words. So be sure to review that. Hint, hint. So at this time, I'd like you to take a moment and write your hypothesis. Again, your hypothesis should attempt to provide an answer to the question, what are some ways protists differ from one another? So write your hypothesis now. All right, we're back for the procedures here, and I have my microscope set up for us to view the 4 different specimens that we will be examining today under magnification. Now, we will be observing our specimens on 2 different powers, on 40 times and 100 times magnification. And after I get the image of the slide in focus for you, I would like you to pause the video so that you have time enough to illustrate, to draw, to sketch in your observation section of your lab book in order to make your observations. So let's begin with our first specimen. Our first specimen are the amoeba. Amoeba. You can review your notes as to what the amoeba are, but as I get these specimens in focus, we've got to find them first. So here are some amoeba. Don't start drawing yet. Let me get some good ones in view. Ooh, there's some good ones. Let's get a nice collection of them here together. Basically hunting around right now for various specimens on the slide, and that involves moving the slide around, in my case moving the whole stage around, adjusting the lighting, making it so that we can see them, and using the coarse adjustment knob first and then the fine adjustment knob to fine tune it. So this looks like a nice little collection of amoeba. And so what I'd like you to do is start drawing these. And again, this is the amoeba, the first amoeba circle under 40 times magnification. You can see some varieties here of the amoeba, but notice, if you will, and I don't know if we can see this, yeah, you probably can't see that with the cursor, but notice up in this one, the darker colored one, notice these protrusions from the amoeba as you're drawing them. What do you think those are called? What do you think those are called? I'll give you a hint. They are false feet. That's how they move around. And if these amoeba, and this is a prepared slide, so all of the critters we're looking at are no longer actually alive. Their lives have been donated to science, and so that's why they're not actually moving around the screen. But you have to remember that these are three-dimensional. They have depth to them. So if you use your fine adjustment, you can actually focus in on different layers of them and get them better focused at different depths of their existence. But keep in mind that they are not only three-dimensional, but when they are alive, they are moving as well. So these false feet that you see protruding out are dynamic structures that ooze and pull, ooze and pull. And do you remember what they're called? Pseudopods. So take a moment, if you need any more time, pause this video to illustrate with 40 time magnification. And now I'm going to zoom in to the 100 time magnification. And let me find one of our specimens here that we were just looking at. Oh yeah, let's get this one. One that looks like an octopus. Let me get into focus here a little bit more for you. We can't even see the whole thing on the screen. 100 times magnification because they are so, well, relatively large. But let's stick with this view here. There we go. Let me get this into focus, and then you can take some time to illustrate what you see, and this is 100 times magnification of an amoeba. So pause the video now for your illustration. All right, we're back. And now we're finished with the amoeba. Make a mental note of the different characteristics or features that you have observed. And again, step 4, size, shape, structure, color. Notice all of those things regarding your amoeba. And now let's move back to the low power, 40 times magnification, as we look at our next specimen, which are the Paramecium. Paramecium. Let me get some Paramecium into view here. Here we go. Hold on. Let's just get this Paramecium into focus. And as I'm focusing, I want you to try to do something in your observations. Draw what you see as accurately as you can, as accurately as you can, but also keeping in mind that they are all to scale with one another. So what you are viewing right now under 40 times magnification is the same scale that you were viewing the amoeba under 40 times magnification. And so while you are illustrating, keep in mind here's some better ones here. The relative, oh yeah, all right, here we go. Oh boy, check these out. The relative sizes of these Paramecium while you are drawing them in your book. Well, I never thought it would be so difficult to talk and to try and move a slide around at the same time. I guess I'm not as talented as I may have thought. Let me just find a good cluster of them here. You know, maybe those are good right there. I will make this our 40 times magnification here of our Paramecium. So if you need to, you can pause the video at this time to draw these cute little Paramecium under 40 times magnification. All right, now I'm going to turn it over to 100 times magnification for another picture here, another illustration. Let me boost up the lighting here a little bit as I look for those that we were just looking at here a moment ago. Ooh, let's bring that back. Now let me get into focus. Ooh, oh yeah, that's a good one. Let me use the fine adjustment here and scoot him around so we can see him. And let me just adjust the lighting a little bit more. Oops, wrong way. Get him a little bit brighter. And whoa, I moved all the way over. Let me get him back into focus. I must have bumped the slide accidentally. Come on back, little guy. Come on back, little Paramecium. Where's the one I was looking at before? Oh, it's like twins. Oh, look at this. Bring these back into view. And let's get it focused a little bit better here. Again, remembering that they are three-dimensional creatures here. I must be on a hill. They keep drifting. And I will give you some time to draw either one of these Paramecium. I will point a couple things out while you're drawing, however. This is kind of cool. This area here, the darker area is the nucleus. And if you look at the lighter area that kind of looks like lips, they almost are. That's called the gullet. The gullet is where the Paramecium engulf their prey. It's like their mouth. It's how they eat. And although it's not all that distinguishable on this these specimens, all around the Paramecium are tiny hair-like structures. Ooh, do you remember what these tiny hair-like structures are called? The cilia. All right, take a moment now and draw the Paramecium under 100 times magnification. All right, hopefully you had enough time to do that. I'm going to remove the slide, return it back to 40 times magnification, lower the light a little bit, and bring in our next specimen. Our next specimen are Euglena. Euglena. And here are our cute little keyword. That's a little hint for you. These Euglena. So there's a good view. So I'm going to give you some time to draw and illustrate what you see with the Euglena here. And again, notice the relative size of the Euglena, the relative size in comparison to the other protists. Notice the relative sizes of these Euglena. And there are quite a few of them on this particular slide. So take a moment and draw Euglena. Okay, that was 40 times magnification. Now let me head over to 100 times magnification. Adjust the lighting here. There we go. And let me find some individual Euglena. Here we go. Let's focus a little bit better. And so this is 100 times magnification. Take a few moments to illustrate Euglena under 100 times magnification. All right, and so that is it for the Euglena. I'm going to head back again to the 40-time magnification, and we're going to finish up with my favorite, Diatoms. Diatoms. These I just think are really cool looking. Check this out. To me, it looks like somebody had a pile of glass ornaments for a Christmas tree and stepped on them and just shattered all over the place. So I'm going to leave it right here for this view under 40 times magnification. And again, feel free to add some color to your drawings. 40 times magnification of diatoms. And take notice, this is actually a variety of species. There are many different kinds of diatoms in this particular field of view. Excuse me. I'm just picking out 1, 2, 3, 4, 5, 6. There's at least a half dozen different varieties or species of diatoms here, all of which are pretty cool. But at this 40 times magnification, take a little while and try to distinguish the different species and draw to the best of your ability some of the ones that you see, paying particular attention not to the smudged areas, which might actually be some algae, but rather paying attention to the parts where you see some geometric shapes. Those are the diatoms themselves. And remember, you probably put some of these in your mouth every day when you brush your teeth, because these diatoms are these microscopic two-part shells that are put into toothpaste. And on the ingredients, they're really called hydrated silica. But silica, another word for silicon dioxide, which is sand, which is basically what these critters are made out of. So if you need more time, pause the video for 40 times magnification of diatoms. All right, and now let's head over to 100 times magnification, and I'll try to make this a little bit easier for you. I will zoom in. Let me find an easy one for you to draw, because some of them are a lot more difficult than others, that's for sure. How about, here we go. Let's look at this variety of diatoms, and I'm specifically referring to the ones, not the smudge directly behind me, but the ones a little bit further out and over that look geometrically shaped. There are a number of them on this slide, basically made of 3 lines, but remember, they are 3-dimensional, and they are made up of a 2-part glassy shell. I just think they're fantastic to look at. So I'm going to give you some time. Again, this is Diatoms, 100 times magnification. Draw what you see at this time. All right, and that's it. I'm just going to move around to see some of the other diatoms because I just think they are so wild here. Let's see here. I know you've already drawn your 100 times magnification. I'm just playing right now, trying to find some cool ones because there's some other ones that, to me, look like combs. Maybe you saw them in the 40 times magnification. Some in the background. I thought I saw a really good one earlier. Ah, here we go. Check that out. Look at that. They're just so wild. And if you watch some of the videos earlier in the week, you actually saw how some of these diatoms move around, which I think is also pretty fantastic. All right, so I'm going to move it over to 40 magnification, which is also our low objective power. I'm going to turn my lamp off now, clickety-doo-dah, and I'm going to lower the body tube with the low objective power. I'm going to go get the case, or rather the cover. And by the way, who can tell me what I have just done to my microscope? What is the acronym for storing it under low objective power before I put it away? Hopefully you remembered SLOP. So I'm slopping away my scope until the next time. And so until next time, hopefully you had enough time. Of course, you have unlimited time, really, to pause the video to get your observations. But make sure after you observe your observations, examining, thinking about those bold italicized words, please make sure you write your conclusion and use some detail. Be specific in your conclusion based on your observations as you finish up today's lab. Also remember to study for tomorrow's quiz, and so until tomorrow, I'll say bye-bye.